Alright, welcome back, Honors Algebra 2. Hopefully you guys did well in your quiz. We're going to start talking about absolute value graphs. So the first thing you should see on your note sheet is graph y equals absolute value of x. Well, let's think about this. We could put any x value in here. So the domain for this problem is all real numbers. Okay? But what are my output values? What can my range be for this problem? Well, if we look at this, if we put 0, 1, 2, 3, 4, 5, we're going to get 0, 1, 2, 3, 4, 5 out. Can I ever get a negative y out of this function? Hopefully you guys say no, because you should know that anytime we put a negative x in, we're going to get a positive y out again. So we're never going to be able to get a negative y value. So for this problem here, the range is 0, and including 0, all the way up to infinity. And we don't put brackets with infinity because you can never include infinity since it's not a number. It's just saying it's going forever. So anyway, let's look at a standard y equals absolute value of x graph. The vertex is at 0, 0. Nothing has moved. We will say the orientation is up and the shape is normal. This is like our standard graph. And again, if we graph this, it looks something like this. Now normally the line would be like this if it wasn't absolute, if it was just y equals x. But what happens is this group of values becomes positive. So it makes our absolute value graph look like a red V instead, because this stuff flips up and becomes positive. So that is what an absolute value graph looks like. It looks like a V. So on the same graph as y equals absolute value of x, graph the equations below and find the requested information. Okay, so if you do this in your calculator, let's look at the calculator real quickly. Alright, so that's not it. There it is. So we can put in y equals, I'm going to type in, to get to absolute value you go to math, and I think we saw this earlier. You go over to number, and there it is, ABS. So there's the absolute value of x. I'll put the original in, and let's see what happens when we do the absolute value of 3 times the absolute value of x. Let's see what happens when we do that. So 3 times the absolute value of x. And I'm going to zoom 6, which gets you back to your standard graph. There's our standard y equals. And what happened? Well, the vertex is at the same place, but you would say that this was actually more narrow or stretched vertically, because the y values are being multiplied by 3 for every x value. So with that, we'll say our vertex is at 0, 0. The orientation is still up. It was facing upward. And the shape was narrow because it's being multiplied by 3. Well, this is going to be the same thing. I'm not going to show the graph on this. You guys can investigate that on your own if you want to look at the graph. Pause, get out your calculator, type it in, and see what happens. But you should see that the vertex is still at 0, 0. The orientation is still up, and the shape now is wide because it's now being, the y values for every x are being multiplied by 1/3. What is multiplying x by a constant due to an absolute value graph? It either makes it wider or it narrows it. And again, you can think of stretching or compressing in the y axis for that. On the same graph as y equals x, graph y equals absolute value of x plus 2 and absolute value of x minus 4. Alright, let's look at that then. Alright. So there's the original, and now we're going to do the absolute value of x plus 2. And let's take a look and see what happens. There's the original. Okay, x plus 2 shifted it 2 to the left. Alright. Well, if we want to guess then what x minus 4 would do, you guys make your own guess. I'll pause the video or think about it. If we do x minus 4 though, you should see that it goes the other direction 4 units. So it moved 4 to the right. So that means that we can, so we we graph these. This is 2 left, 2 units left, 4 right. What does adding a constant do to the absolute value graph? It shifts it left or right. This is very important to know. When it's inside the absolute value, it's usually the opposite direction of what you'd think. Plus 2 is actually 2 to the left here. Minus 4 is 4 to the right. Alright, so now we have the next shifts that we have to look at, which are absolute value of x, and then outside of the absolute value, we're going to add 4, and outside the absolute value, we're going to subtract 3. So if we look at these, original, adding 4, and subtracting 3. So now these are our vertical shifts, and if you notice that that the vertical shifts are the same sign as what you would think. This is up 4, this is down 3. So it's the same sign. So up is usually positive, down is negative, but for left and right it's the opposite signs. If it's a plus 2, we're shifting 2 left. If it's minus 4, we're shifting 4 right. So it shifts it up or down. And what do you think changes the orientation? So what flips it downward? That would be a negative sign in front of the graph. So if I made it, for instance, I don't know why it's not, there it goes. If I made it y equals negative per absolute value of x, this would make orientation down. Okay, so that's just how graphs shift. So now let's look at the quick general forms of these equations. Accurately graph y equals negative 2/3 x plus minus 1 plus 2, and then state the vertex orientation and shape. Here's how the easy way to do this. Find your vertex by the shifts. They always start at 0, 0. This means 1 right. This means 2 up. So that means my vertex is 1 right, 2 up. And I'm going to put a vertex there. Now, this negative sign means it's an upside down V. And then we have 2/3. Well, that means we're doing 2/3 of the normal slope. So this is, think of this kind of as your slope of your absolute value graph. 2/3. So that means I'm going to go down 2 and over 3 in both directions. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Because this is the starting point. Now we're going to do it the other way too, because the values, it's going to be an upside down V. So 2, 1, 2, 3. 2, 1, 2, 3. So our graph should look like this. The vertex is at, vertex is at 1, 2. Orientation is down. And the shape, since it's less than 1, the fraction is less than 1, it is wider. Now, you have to be careful with that. If I have a fraction that is like 6/5, that is bigger than 1. It's not every fraction makes it wider. It has to be bigger than 1, or it has to be less than 1 to be wider. Bigger than 1 gives us narrow. Alright, now we have to do the opposite. Let's write an equation. Well, we need the vertex, so there's our vertex at 3, negative 4. And the slope here is 1, 2, 3, 1. So we have a 3/1 slope. Its orientation is up, so we don't have to worry about a negative sign. So let's write it. Y equals, it's a positive 3/1 slope, so you can just say 3, absolute value. It's a 3 to the right shift, so we're going to have an x minus 3. And then it is a downward shift of 4, so we're going to subtract 4. There it is. That's all you have to do for that. Alright, we are going to now use our calculator to do this one. For the corresponding x values for the given y values, find the corresponding x values for the given y values. Round to the nearest thousandth, 3 decimals, always. We use intersect. Yeah, we use the intersect function. So here's what you do. You throw this into y1, you throw this into y2. So I'm going to do that right now. y1 is parentheses negative 8 over 5 math absolute value of x plus 10 minus 9.5. You also have to think about your window here. The graph is shifted down all the way to negative 9.5. And we want to know when it hits the line y equals negative 19. So that's going to be very far down. So if I just graph this right now, I'm just going to hit graph just to look at it. We don't really see anything. Because remember, this is shifted 10 right and 9.5 down. So the graph's over here. So you have to change your window to see it. I want my x min to be negative 20, and I want it to go to 0. I want my y min to be, I don't know, negative 30, and my y max to be, since it went down negative 9.5, I'm going to say negative 8. And if I graph this now, I should be able to see, there's my absolute value function, and there is the line where y equals negative 19. What I want to find are these two x values that solve this equation. So here's how you do it. You hit second trace, so second trace, and there's a function, or there's an option called intersect, number 5. I'm going to just hit number 5. I hit down to get onto the horizontal line and move closer to the intersection point that I want. And then you have to hit enter 3 times. 1, 2, 3. And there it is. My x value is negative 15.938. Negative 15.938. And then we have to do it one more time. Second trace 5. And you have to just move over. Oh, see, this is why I like to hit down first, so I'm on the straight line. You have to get closer to that other intersection point so it'll work. Once you're close enough, you can start hitting enter, 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 enter. And the other one is negative 4.063. So x equals negative 15.938, and it equals negative 4.063. That's how you use your calculator to find intersection points. We will do that a lot this year. So, we'll keep practicing that. Last problem, front of a roof with its outer edges 8 feet above the ground can be modeled by this equation with x and y in feet. Graph the function, interpret the domain and range in this context. So you have to remember, it is 8 feet. The outer edges are 8 feet, and the vertex, so our vertex is at 9, 14, based on this equation. We have a 9 to the right and 14 up. Okay, so let's look at this graph. The outer edge of the roof is 8 feet of the ground. Let's start that at 0.8. Well, actually, let's see where that is. I'm going to graph the equation. So it's negative 2/3. Absolute value of x minus 9. And then it's plus 14. And we don't need the second line. And our window needs to get back. Now we're looking at the positive quadrant because our roof's not going to be negative. So I'm going to say our x goes from 0. We know the x value is at 9, so I'm going to say it goes all the way to like 20. And then the roof height starts at 8, so I'm going to say the minimum 0, but we know it goes up to 14, so I'm going to say 15, just so I can see what this roof looks like. Okay, and there's my roof. Now obviously the roof will not keep going in real life because this line will hit the ground and then go under the ground, and that would be weird for a roof to do that. You would not want your roof of your house to be doing that. So it starts at 8 up. Let's just double check to see that that is where that is. Let's look at the table to do that. Second graph gives you your table. And if I go to my x value of 0, and just make sure that that's the outer edge, yeah, it's at 0.8. So I'm going to go here and say, all right, this is 0.8 my vertex is at 914, which means that it went 9 units this way, which means it has to go here another 9 units in the x direction, and then it goes back down to 8, and now it looks like the top of a roof. So my domain here is not all real numbers because we're talking about a real thing here. We're talking about a roof. My domain would actually be all x values such that x is between 0 and 18. And we're including those. I know 0 isn't a length, but it starts at 0 because there is a length there. There's an output there and an output at 18. The range for this are all y values such that y can be anywhere from 8 up until 14. Okay, remember, range are your outputs. Y can be between 8 and 14 for my roof. X can be between 0 and 18 on the as my input values. Okay, so when in doubt, just throw the equation in to see what's going on and graph it. The most important thing, though, is understanding the shifts from the beginning and graphing them. Okay, the shifts are important. If you don't know the shift, how to shift it, everything when we get into quadratics, we're going to be using vertex form also. So vertex form is very important to remember. Okay, if you have any questions, again, leave a message on Edmodo, and I will go over anything you guys want tomorrow. We can redo letter D if you still want to talk about that one, or we could do more things. So just let me know, and I hope, and then I guess we'll see you guys in class.